Good morning. It's Tuesday, and we're going to continue with our work on percents. Okay, it's so nice to see you all, even though I can't see you, but you can see me. We're going to talk more about interest today. Yesterday, we talked about simple interest, and that is where every year, at the end of the year, interest is applied to a loan or to an investment, but it's only based on the very original amount. So if I invested $100 for 5 years at 10%, then every year I would get $10 added on to that investment. So at the end of the first year, I'd have $110. At the end of the second year, I'd have $120, and so on until after the end of the fifth year, I'd have $150. Does that make sense? So that interest, simple interest, means it's only ever interest on the original amount, which is called the principal. Compound interest is different. Compound interest means that interest is applied along the way to the whole amount, which means if it's an investment, you earn more. So if I invest $100 at 10% for 5 years, then at the end of the first year, I'd have $110. But at the end of the second year, I would get 10% on that $110, which is a little bit more. And then whatever I've got at the end of the third year, whatever, I would get another 10% on that whole amount. All right? So there's a formula that works for this. Instead of showing us the interest, it shows us the total amount of the investment or the loan at any one time. So it looks like this. Actually, let's start down here and then we'll go back and talk about the formula. So let's say that we've got this problem. You invest $100 at 5% interest rate, for 4 years. All right, let's take a look at that. $100 is always a great simple example because you can just sort of see it in action because we're dealing with percent. So this is my principal, $100. After the end of year 1, if you grab your pretty beautiful, wonderful calculator, right, and I say 100 times, how do we add a percent onto a number? Oh, that's right, we multiply it by 1 plus the percent. Remember that? If we're doing sales tax, if it were 5% sales tax, then I would multiply by 1.05. Well, if I want to add interest onto an investment, then I can do the same thing, right? It's just adding a percent onto that. So I'm going to do 100 times 1.05 equals, whoops, I don't know why I got an error. Oh, I have two multiplication signs. Hold on. Let's try this again. 1.05 equals $105, and we can do that with mental math. That's not hard. So if I do this again at the end of year 2, I'm not adding $5 on at the end of each year. I'm adding on 5% interest on whatever the total amount is now. So I've got 105 in my calculator times 1.05. If you're not doing this, pause the video and go grab your calculator and let's do it. Equals 110.25. Well, now I can take that, right, and do that number here. Leave it in my calculator times 1.05. And I get 115.76, which I rounded. And if I leave that in my calculator times 1.05, then I get 121.55. Now, that seems okay for me to do for a 4-year investment. I can put that in my calculator 4 times. It's not too irritating. What if it's a 30-year investment? What if you're investing in some kind of investment that you want to use 50 years from now, and you want to just have an idea of how much might be in that investment at the end of 50 years? Well, let's take a look at the formula that helps us do this, okay? So the total amount of any investment, let's just keep talking about investments, even though loans, the total amount of a loan is the same, it works the same way. But if you invest the principal at this some interest rate, well, each year it gets, or each time it gets compounded is what this is called. Interest is compounded, meaning it's interest on interest on interest, each time it gets compounded at this interest rate, it gets multiplied by 1.05 or 0.75 or 0.23, whatever the interest rate is, right, as a decimal. And it gets multiplied by that a certain number of times. In fact, the number of years. So what does an exponent do? An exponent says we're going to do this. We're going to multiply by this thing this many times. And that's what we did here, right? We did 100 times 1.05 times 1.05 times 1.05 times 1. We did it 4 times. So let's see how we could write out this problem, this $100 at 5% for 4 years. If I use the formula instead of this chart, boy, it seems a lot quicker and easier to me. Quicker and easier is always good, right? And so I'm going to say that amount equals 100, which is the principal, times 1 plus the interest rate, 0.05, to the 4th power. Let's think about how we're going to use our order of operations to make that happen in the calculator. So I'm looking at this right here. I'm going to start with the parentheses, right? PEMDAS. So 1.05, I can just do that in my head. Exponents to the, remember you're going to use your little caret if you've got it. If you've got a different calculator, maybe it's x to the y or y to the x. If you're using your Chromebook, I'm not really certain what it looks like. But so I'm going to do to the 4th, and I usually do equals. And you'll get 1 point something, right? And I get this 1.21550.625 times 100 times the principal equals 121.55 rounded. And that's my answer right there. So on the worksheet that I'm giving you, there are just these same kind of problems, about 7 of them for you to do. I wrote out one problem at the top, and I wrote the formula nice and big, okay? And then I wrote out number 1 as well as an example. So please give those a try. This is totally doable. Compound interest is a great thing. Someday you will understand that a little bit more. We've talked about doing a project. I don't know if we'll be able to do it or not, but maybe we will give it a shot. All right? I hope that you all are doing well, and I will talk to you tomorrow.